Okay, today we're going to continue our discussion on organic molecules, and as you can see, we're moving on to lipids. Lovely lipids, as I like to say, or everything you ever wanted to know about fat and its relatives. So let's get started. There are two types of lipids. All right, let me get my pointer ready here. Some lipids are in the fat family, which we will actually talk about first, and most of you know that fat is a type of lipid. But what might surprise you is cholesterol is also a type of lipid. In fact, the whole steroid family of molecules is a type of lipid. But we'll get to those later. So let's deal with first the fat family. All right, but I lied. Before we get to the fat family, let's review characteristics of all lipids. All right, when you look at the fat molecules and when you look at the cholesterol molecules, you are going to see they look nothing at all alike. So why do we put them in the same family? Well, all lipids, whether they look like fat molecules or cholesterol molecules, they are all hydrophobic. So you should know by now that hydro means water and phobic means fearing. I think this is a vocabulary word in chapter 4, one of your chapter guides. I think that's the right one. Maybe it was chapter 2, one of them. But at any rate, phobic literally means fearing. Now, do you think a fat molecule is afraid of water? Oh, I'm afraid of water. No, I don't think so. So when we say lipids are hydrophobic, it means they do not dissolve in water. So all lipids, whether they're in the fat family or cholesterol family, they do not dissolve in water. In other words, they're all nonpolar. And that is their universal characteristic. Another characteristic of all lipids is they are made exclusively of carbon, hydrogen, and oxygen atoms. So now let's get going onto the fat family. All right, what you are supposed to know, because I've already told you this, is that triglyceride is the fancy word for fat. It's the scientific word for fat. So this is something we went over after the South Beach Diet article. You should know that one molecule of triglyceride is the same thing as one molecule of fat. So what does a fat molecule look like? How do you make a fat molecule? Do you take a skinny little molecule and feed it a lot? No, I'm sorry, bad joke. One thing you should realize when I show you a fat molecule, it's not a polymer. So let's take a look at it. To make a triglyceride or a fat molecule, you take one molecule of glycerol and you combine it with three molecules of fatty acids. So I think we're going to have to go back to a different color here. All right, so this is a fatty acid. And because it's an organic molecule that calls itself an acid, fatty acid, you should notice it has the organic acid group, also known as a carboxyl group. So remember, C double bond O, single bond OH, is either called the organic acid group or the carboxyl group. And fatty acids, all right, all have the acid group. So one fat molecule is made from four molecules. The backbone is glycerol, and it has three fatty acid tails. And as always, how do you make a larger biological molecule from smaller biological molecules? With dehydration synthesis. So you see there's an OH here, an OH here, the HOH elope, and this happens not one time but three times. So to make a fat molecule, you have to lose three water molecules. And here you have it, one great big ugly fat molecule or triglyceride molecule. It has the glycerol backbone and the three fatty acid tails. And this is convenient because it fit on one side, but this molecule is a little bit of a lie, because let's count the carbons in the fatty acid tail. 1, 2, 3, 4, 5, 6. That's way too short. A legit fatty acid tail would have somewhere between 18 and 24 carbon atoms. So this is not drawn to scale. Let's look at the next slide. All right, again, you have the one molecule of glycerol. You should recognize, by the way, this functional group, it's the hydroxyl. And to each hydroxyl interacts with a carboxyl to have dehydration synthesis. So let's look at this fatty acid. You do not have to memorize any of the names of these fatty acids, by the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, this has 14 or 15 carbons. This is close to reality. A typical fatty acid tail has between 18 and 24 carbons. So a typical fatty acid tail has between 18 and 24 carbon atoms. So for this fat molecule, this triglyceride, this is much more realistic because it's, as you can tell, to the skinny little glycerol backbone. You have 3 long, long, long fatty acid tails. And that's a disgusting fat molecule. All right, moving right along. I'm imagining most of you want to eat healthy and live a nice, long, healthy life. And so when it comes to fat molecules, which should you eat? Should you eat more saturated fats or should you eat more unsaturated fats? Let's explore the differences. So first of all, which is unhealthy? Do you know? Saturated fats are what you want to avoid. You can eat some, but just not in great quantities. So what's the problem with saturated fats? Too much promotes atherosclerosis, the thickening of the arteries. So here we have a little diagram of a heart, and here we have some atherosclerosis. So they've blown up this little capillary here, and what you have lining these capillaries, these blood vessels that feed the heart, is plaque. So these are cells that have engorged themselves on saturated fats. Yes, the cells have engorged themselves on saturated fat, and what that does is narrow the blood vessel, so it narrows the flow of blood. Well, the heart pumps blood throughout the body, including itself. So what does the blood carry to the heart? Well, the blood carries oxygen gas to the heart. Yeah, that's supposed to be an O2. The blood carries oxygen gas to the heart. So as you narrow this passageway, you're restricting the flow of blood and therefore of oxygen gas to the heart. Well, why do the heart cells need oxygen? You should know this by now, to get energy out of its food. And do you think the heart cells are using a lot of energy? Heck yeah. So the heart needs to pump oxygen to itself so its cells can do cellular respiration, have lots of energy to keep beating. If this narrows, boom, you can have a little mini heart attack. So you want to avoid too much saturated fat. Well, how do you do that? Well, let's look at the differences between a saturated fat and an unsaturated fat. So again, this shows you the fatty acid tail of this fat molecule, and it's duplicated 3 times on this fat molecule. It doesn't have to be the same, but on this fat molecule, it has the same exact fatty acid tail. And this molecule right here that you see is a saturated fat, a saturated triglyceride. Here's an unsaturated triglyceride. So let's look at it. Saturated, unsaturated, saturated, unsaturated. Does any difference pop out at you? Well, let's look at the bond between carbon atoms. In a saturated fat, if you look at the bonds between carbon atoms, these are all single covalent bonds between carbon atoms. Now, don't worry about this one right here. That's carbon double covalent bond oxygen, and that's part of the carboxyl group. So all fatty acids are going to have C double bond O. We're looking at the bonds between the carbon atoms. Here they're all single covalent bonds, and here we have at least one double covalent bond. In fact, we have 1, 2, 3. So if you have a saturated fat, all the carbon-to-carbon bonds are single covalent. And if you have an unsaturated fat, you have at least one double covalent bond between the carbon atoms. So if you only have one double covalent bond, it's called monounsaturated. If there's more than one, if you have many, it's called polyunsaturated. So this fatty acid tail has 3 double covalent bonds between carbon atoms, so it's polyunsaturated. And I noticed a lot of you, when you read the South Beach Diet article, you weren't really sure what monounsaturated and polyunsaturated meant. So hopefully you know. So what does that mean? Well, since we have all single covalent bonds between the carbon atoms, that means we have as many hydrogen atoms as we can possibly cram onto here. Because if you go to the unsaturated, wherever you have a double covalent bond, well, you don't need a hydrogen atom there. That carbon atom has 4 covalent bonds without another hydrogen atom, right here, the same way. That carbon is happy with 1, 2, 3, 4 covalent bonds. If that was a single covalent bond, you could add another hydrogen. So if we go back, a saturated fat carries as many hydrogen atoms as possible. In fact, that's where it gets its name. If you have a sponge that's saturated with water, does it have a lot of water or a little water? It has not only a lot of water, it has as much water as it can possibly hold. Well, it's the same thing with the saturated fat. You cannot possibly put any more hydrogen atoms on there. All right. Let's erase this a little bit. There we go. All right. Let's clean up our act a little bit. All right. All right. So on here, on the saturated fat, you cannot put on any more hydrogen atoms. It's completely full. But on the unsaturated fat, all right, there we go. It's always nice to clean up a little bit, right, when things get messy. On the unsaturated fat, you could put more hydrogen atoms. If we turn that double covalent bond into a single covalent bond, we could add more hydrogen atoms. All right, so again, that's where the fats get their name. Saturated fats carry as many hydrogen atoms as they possibly can. Unsaturated, because of the double covalent bonds, you could add more hydrogen atoms. But here's the problem, ladies and gentlemen. If you really want to try to eat healthy, if you're looking at the fat on your dinner plate, can you count the number of hydrogen atoms? Can you count the number of double covalent bonds? I don't think so. So can we see another difference? Well, if you look at the molecule yourself, maybe you'll notice that these fatty acid tails are actually kinky, whereas these fatty acid tails are straight. So these have a little kink. In fact, you'll notice wherever there's a double covalent bond, there's a kink in the fatty acid chain. So maybe this is something we can deal with. So we have a little summary chart on your slide, and you should be filling this in. So saturated and unsaturated fats. Let's review. What are the covalent bonds between atoms like? Maybe I'll go back to yellow. Remember, for saturated fats, you have nothing but single covalent bonds between the carbon atoms, correct? But for the unsaturated fats, you have at least one double covalent bond between carbon atoms. If you only have one, it's monounsaturated. So the number of hydrogen atoms, well, here you have the max, right? So I'm going to put more. Well, it's not. It's as many as you possibly can get. But here you have fewer hydrogen atoms. You could add more, so that's more and less. So let's get back to the fatty acid tails. On the saturated fat, yes, I'm a lovely artist, the tails were all straight. But on the unsaturated fat, the tails were kinky. So now let's think a little bit further. Which could pack more closely together? Which do you think, when they're lined up side by side, doing the can-can together, which fat molecules could pack more densely? The saturated fat molecules or the unsaturated? You getting the idea? Yeah. The saturated fat molecules can pack more tightly, more densely, whereas the unsaturated, because of their kinky tails, are going to spread out more. So now we're getting to something we can observe. What's their state at room temperature, solid, liquid, or gas? Well, because a saturated fat, the molecules are so packed tightly, densely together, they tend to be solid at room temperature. Whereas the unsaturated fat, they tend to be liquid at room temperature. So that, ladies and gentlemen, is a way that you, by looking at your dinner plate, all right, can tell the difference between saturated fats and unsaturated fats. And what I want you to think about, talk about with your bio buddies, is the food sources of saturated and unsaturated fats. So what do you eat, or what have you seen other people eat? What foods, specific foods, are sources of saturated fat? And what specific foods do you eat are sources of unsaturated fats? And be prepared to share your answers when I see you in person on Zoom, right? All right, we'll see you next time.